Hello guys, welcome to the ASTRO. So in this tutorial, you are going to learn about that how to transform velocity component from one frame to other frame using Lorentz transformation equation in a special theory of relativity. Okay, so let's see how to do it. Okay, so for doing that, we have a benchmark uh, uh, in terms of frame S and S prime, and you can see that their origin is O and O prime, and the S prime is moving with velocity v in positive x direction. Okay, so imagine we have say that particle point and having velocity say ux, uy, and uz, having its three velocity component. Okay, so our goal is that what will be this velocity component in say S prime frame. So what will be say uy prime, ux prime, and uz prime in your S prime frame. So this we have to calculate. Okay. So for doing that, we will be using Lorentz transformation equation. Okay. So for doing that, we'll go to Lorentz equations. Okay. So we know that the Lorentz transformation connects a spatial and their time coordinate mixed with each other. Okay, so for time being, we can write say x prime equal to gamma x minus vt. Okay, so qualification 1, and then similarly y prime equal to y, and then z prime equal to z, and then t prime equal to gamma t minus v x by c square. Okay, so you can label it as 2, then 3, and equation 4. Now this you got. Now what to do? Take differential, take differential take differential of the of equations 1 to 4. Then you can write say this equation as dx prime equal to gamma dx minus v is constant, then dt, call it as a 1 prime, and then second one as dy prime equal to dy, third one dz prime equal to dz, and then fourth one as dt prime equal to gamma dt minus v dx by c square, and call it as a 2 prime 3 prime and 4 prime. So now our stage is set for obtaining velocity in s prime as ui prime, ux prime and uz prime. Okay, so what we will do? Okay, so for ux prime. Okay, so what we will do? You can write ux prime equal to dx prime by dt prime. Okay, and then in the limiting case, and then you divide. Then what you do? You divide 1 prime by 2 prime equation. Okay, sorry, 1 prime by 4 prime. These equations you have to take the ratio. Okay, so what to do? You just put here gamma dx minus v dt divided by gamma dt minus v dx by c square. So gamma gamma get cancelled, and now what to do? You do one more step. You divide numerator and denominator by dt. Okay, so this becomes dx by dt minus v dt by dt, and then dt by dt minus then v by c square dx by dt. Okay, so this you get. Now you can write dx by dt as u. Okay, so here ux prime equal to u ux minus v, and then it goes dt by dt equal to 1, then it's 1 minus v by c square into ux. So in the more good format you can write ux prime equal to ux minus v minus 1 minus ux into v by c square. So this relates your velocity from s frame to s prime frame for a particle, and I call it as a equation A. So you can see that for x component only x component is related to each other of a particle. Now in a similar footing you can go to find, say I want to find, okay, so find ui prime. Okay, so for that take a ratio of take ratio of 2 prime divided by 4 prime. Okay, and now do the algebra. Okay, so what you will get? Ui prime equal to dy prime by dt prime, and then it's become dy, and then gamma dt minus v dx by c square, Now to do the same thing, divide numerator and denominator by uh, t. So this becomes dy by dt, and then gamma dt by dt minus v dx by dt 1 by c square. So finally you can write it as uy prime equal to uy, because dy by dt you can write as a uy then gamma 1 minus v then ux by c square. Okay, so this is got your second, I mean y component of velocity in your s prime frame for a given uy velocity in s frame. Okay, so this called as a b. So here you can see that in y frame, in uh, s prime frame, the velocity of x component is also affected. I mean, in y frame, velocity of x component of the particle has been included. So it's also affect the x component, not the only y component. So on a similar footing, you can also write uz prime equal to uz divided by gamma 1 minus v then v ux by c square. So this way you can relate your all components ux to u prime, uh, uy prime to uy and uz prime to uz. And okay, so this also write say ux equal to ux prime then 1 plus v ux by c square. Okay, so this way you can write your this way you can write your uh, transformation in an indirect way. So basically, this is like your indirect indirect transformation. Okay, so now come to equation A. So equation A. Okay, so equation A we have ux prime equal to ux, then 1 minus b ux by c square. Okay, so suppose a special case where uy and uz equal to 0. So particle is going in only x direction. Okay, so what you can write? You can write ux equal to u equal to you can write u prime equal to u 1 minus v 1 minus v and then u by c square. Okay, so basically you can see that this is a velocity subtraction. This is velocity subtraction equation. Okay, now uh, you can also write its inverse. I mean, just goes v2 minus v and prime to non-prime. Okay, so you can write u equal to u prime plus 1 plus v u prime by c square. So this becomes your velocity addition. Okay, so this way you can drive for your special case where u and u prime and your u and uz equal to 0.